Good morning, everyone. I'm Anushka Wickramaratne. Today, Tech Talk is about performance engineering essentials. Because in today's world, performance topic is not just downloading a tool or like JMeter or whatever and executing tests. So, performance engineering is a broader topic and complex area. So let's see the agenda. Importance of UX, performance testing versus performance engineering, three types of performance assessments upon time and impact. Why do we need proactive performance assessments? How to achieve proactiveness, attributes of performance, how to assess performance, what we need to focus on, what is the assessment process, where can we do the assessments, how to do the assessments, like tools, etc. And finally, APM tools. Okay, so this presentation I'm divided into two steps. First one is lay the foundation. So this is a kind of icebreaker, guys. So you can see customer or end user is really happy. You can see a nice loving mermaid. In our case, that is our application. But in the other hand, you can see a complex backend, right? You can see ugly dragon. But since the UI is good, performance is good, the functionality is good, user is smiling and no customer complaints. Let's go to next slide. So user experience. So user experience can make or break a business. So basically we have our own perspective about this. We are basically talking about the functional aspect most of the time. So basically it's true that we have different kind of tracks, parts like performance, security, etc. But when we are dealing with a custom application, we need to concentrate on functional, performance, security and other aspects because those are the main pillars. So these are under UX umbrella. So we cannot say let's do performance assessments later. So if we are doing like that, then there will be big issues. So please think. So then what is the difference between performance testing and performance engineering? So performance testing is all about testing web application or maybe APIs by simulating end users. We can say load to check speed, scalability, reliability, etc. The entire goal is to find bottlenecks, bugs, and eliminate them. But performance engineering is kind of proactive engineering end-to-end process to catch bugs as early as possible. The main thing is in performance engineering, not only testers, I mean developers, BAs, and even the product owners should participate to achieve this. So there are three types of performance improvements aspects, I would say, upon time and impact. First one is reactive. So what is reactive is basically reactive performance is like improve or correct the issues after it occurs. So as the name implies, this is basically important, but there will be a cost. Sometimes it is very high. And what is then proactive? Proactive is all about getting the requirements, correct requirements, do the planning, do the testing as early as possible in the life cycle. So that is basically engineering. So the third one, predictive. So we can say third one or part of two because predictive also the engineering aspect. So I will do more explanation in the later slides about predictive and also the proactive performance. So why we need proactive performance assessments? Basically, this is very important, guys. So for quality assurance engineers, for developers, so cost of quality. So in cost of quality, because if we are dealing with cost, if we need cost, we need to incur money or time. So there are two aspects. So good cost of quality. So good cost of quality, we have two areas, is appraisal cost and prevention cost. In performance perspective, the appraisal cost will be like performance testing, fixing bottlenecks, like pre-testing or automating performance in CI/CD. And what is prevention cost? So there's a cost. So basically aim for like gathering SLA requirements, architecture reviews, performance testing trainings, awareness sessions, and also the process, okay, establishing processes. And then poor cost of quality. So that is internal failure cost and external failure cost. So what is internal failure cost? Basically failures found by internal people, the bugs and also downtime, etc. So can be like QAs or developers. But what is then external failure cost? So that is huge. Say for an example, loss of customer sales due to performance, reputation. Maybe we have to change the design. So I will give you an example later stage. Finally, loss of customer. Okay, so this part is very important to understand. So if we need to have quality, we have to incur some cost, but should be good cost of quality. So there will be a slide for example as well in Shopzilla side. How to achieve proactiveness? How to achieve this? So basically we have two things, that is shift left testing and shift right testing. So what is shift left testing? Shift left testing is all about testing early as possible in the life cycle. Say for an example, gathering user requirements before the designing. So we are basically gathering requirements, I mean the functional requirements more or less, but are we gather the performance requirements? Say for an example, how many concurrent users we need to handle our project folio. So we have certain projects. So are we gathering those? And after 2 years, what will be the user load? Something like that. So those are very vital. And performance testing, not by performance engineer or QA engineer, it should be done by the developer as well. But as early as possible. And CI/CD, are we automating something, etc. And also shift right. What is shift right then? That is basically after going to the production. So basically shift right, we can say application monitoring, API monitoring, capacity planning. Say for an example, let's say production, we have data and we can plan the forecast capacity of the customer. So are we doing that? So we should do. So that is basically, we can say this is predictive performance. We can predict. In step 2, so let's learn some testing basics, because in engineering aspect, testing also there as a part. So attributes of performance. So we have basically, for me it's 4, but traditionally there are 3 attributes: speed, reliability, and scalability. So what is speed? Speed is all about how user feel the system. Can he do things faster? So let's see the figures. So how fast is fast enough? So in like 10 years back, 5 years back, maybe we are telling the SLA like 5 seconds, 3 seconds or something like that. But these are the figures published by Google. So you can see 0 to 100 milliseconds, instant. 100 to 300 milliseconds feels sluggish. 300 to 1000, my machine is working. 1 second, mental context switching. 10 seconds, I'll come back, tata, bye, goodbye. So the rule of thumb is stay under 250 milliseconds to feel fast. So can you imagine? So at the moment also we are basically targeting to achieve like 3 seconds, 4 seconds, 5 seconds sometimes. These are the future figures, guys. So they are trying to achieve this. Now, what is reliability? So reliability is that the application should perform even when unexpected event occur. Say for an example, I previously work in a safety critical application, so pharmaceuticals. So as a barcode should be printed in every packet, but let's say due to error in the application, it is not printed and going through the line. So there's a line reject. So it is also governed by the application. So it should be rejected. So it's a mechanical arm. So it should be rejected. If not, there will be a lot of consequences, like customers can, because it's drugs, customers can sue us. So likewise, the customer should rely on. So what is then scalability? So scalability is basically, there are 2 things like hardware scalability and also the application scalability. So we are more or less dealing with the hardware. So in this aspect, we have 2 scenarios, that is scale up and scale out. So basically scale up is we are adding resources to the same server machine. Scale out is basically if the user load is very high, then we have to have other servers, many servers to distribute the load. So in nowadays cloud environments, those are not that complex. And finally, the confidence. So this is basically my attribute. So if we have speed, if we have reliability, if we have scalability in your application, we have the confidence. As developers, we have the confidence. As users, they have the confidence. Okay, so these are the main attributes of performance. So how to assess performance then? Testing types. So we need to test that, right? So in backend perspective, we call it as multi-user perspective. So in multi-user perspective, we have several testing types. First one is load testing. So load testing is testing the intended load. Say for an example, in SLA, service level agreement, they say, okay, 1000 concurrent users, we can test that, whether it's okay. And then test testing. This is bit of, misunderstood. We cannot always break the system. So that is misinterpreted. So we have basically 2 ways. That is disruptive or non-disruptive. So in non-disruptive, say for an example, we can add 2000 concurrent or 1500 concurrent users, then 2000 concurrent users and see how it behaves. And disruptive, yes, Then we have to do, like, we have to have papers. In papers, we need to sign it, and we need to have a monitoring team, monitoring application, something like that, to break the application. So in stress testing, you need to see that there are two ways. And then endurance testing. What is endurance? Why we need to do endurance? Say for an example, let's say in 1BT we have an e-commerce site, and let's say we are in Christmas season, so we need to do endurance test. Basically, the description is adding virtual load within a long period of time. Say for an example, from December 20th to December 26th. So that period, there are huge load. So we have to do endurance. And there's spike testing. What is spike testing? So we have a very good example in Sri Lanka. So after, some results published, you can say no one can log into that. So for that, so if you 1VT have that sort of a application, that is why basically, as I told you, we need to gather those data. So if we are building some same kind of application, we need to do spike testing. Spike testing is basically adding big load within a short period of time. And then volume testing. So basically the application is have a lot of data. So we need to do volume testing, and we call it as flood testing as well. And scalability testing. So if we are dealing with load balancing system, etc., and if we need to test that, whether our logic is working, so there are logics like round robin, etc. So we need to do scalability testing and see, okay, now from this point, the requests are going to that server. So then this is basically multi-user perspective. Then we have the single user perspective. So we need to test with the load and also without the load as well in the front end. So there's a front end testing mechanisms as well. So altogether we have, multi-user perspective testing as well as single user perspective testing. And these are basically, I want to mention, popular testing types, but other than that, there are many. And what we need to focus on. So as I told you, we have product front end and product back end. And for product back end, basically we need to focus on, but not limited to, web and application server performance, database specific performance. You need to see the database, network issues, and application logic and DB logic issues. So there can be application logic issues and third-party application issues. If we are dealing with a third party and the third-party application is not working, then it will impact to our application. So we consider that as well. So memory leaks. Are we working on memory leaks? And server locations. Okay, so let's say if we are accessing the site from Sri Lanka and the server is on America, there's a big latency, right? So it will impact to the performance. So for that, basically the industry is working on the CDA, content delivery net. I think you know more than me. And for front end, application rendering rules. So there are rendering rules in the front end side. So I will do another presentation on that. And other one is bad requests. Whether we have bad requests, too many requests, and so on and so forth. So there are many. So these are the main focus areas. And then for anything, we need to have a process. We can't just download and do a test. We need to plan it well. So say for an example, if you are basically planning for a front-end performance assessment, we need to gather requirements first, okay, and then evaluate the system. So we need to come up with a proof of concept if we need, and then we need to have a strategy of how we are doing that, then strategy document, and also then front-end performance assessment, and then assessment report, and then we need all data to compare. So we need to have those figures, graphs, etc., and then we need to tune the front end, and then reassess the front end, and then we need to have a report with the compared results to present to the customers. So in that case, we need to have a plan, we need to have a process. So likewise, we can build a process for the back-end testing as well. But I am recommending to do front-end first approach. Okay, then where can we do the assessments? Okay, so basically we have three ways. That is on-prem. So on-prem is the servers, the load generators, console, all the things are in on-premise. And then the cloud. So now we have a lot of cloud tools. So I will later show you. There are a lot of cloud related tools. Okay, so in 1BT, most of the applications are in cloud. So we can use cloud related tools. So all the load generators, consoles, everything in the cloud. And then hybrid version as well. So the servers are in on-prem, but load generators and the console we can take from the cloud. So that is hybrid version. So likewise, we have three places to do these assessments, etc. And then how to do the assessments tools. So we have a set of front-end tools. So we can use developer tools. Say for an example, in the browser we have that. So using the critical rendering path, we can analyze a lot of performance bottlenecks. So nowadays, in most of the applications, they have performance bottlenecks in the front end. So for that, we can use developer tools. We have a web page test. We have Google Lighthouse and also Pindem. Okay, there are many tools. I have added only few for your reference also. And then backend tools. So we have JMeter, we have LoadRunner, the WebLoad. So basically, I work with WebLoad as well. So LoadRunner and WebLoad is very expensive tools. And then NeoLoad and BlazeMeter. So basically, NeoLoad and BlazeMeter, if I am not mistaken, those are cloud-based tools. Others are basically standalone, and Apache JMeter is an open source one. Other thing is, normally we say BlazeMeter is the cloud twin of the JMeter. So these are some of the backend load testing tools that we can use. More or less, we are going for JMeter and BlazeMeter because others are quite expensive. And then this is also very important. That is APM tools. What is APM? APM is Application Performance Management Tools. So this is also a thing which we can propose to our customers. So in other words, how to predict the predictive performance. So after we deploy it to production, we can say, okay, by looking at those information, we can predict. So we can notify or tell customers there are tools like this as well for the production service. So we have App Dynamics, we have New Relic, Dynatrace, and .com monitor. So it's only few tools. There are many. Pindem, that is also a kind of monitoring tool, and Monitis also. So there are many application performance management tools in the industry. So we need to propose, we need to work on this as well. And for Azure, there are Azure Monitor for I think hardware and application insights to the monitoring in the application side. And you can see dashboard. So this is I took from New Relic. So you can see live users and mobile clients and throughput, response time, and page views. So there are a lot of information, as well as there are other features like database or the query errors, etc. So we can get a lot of ideas or information from these tools. So we call it as APM tools, and it is more or less a predictive performance, and also it is a part of engineering. And then, as I told you, this is a kind of real example. Shopzilla is a white paper as well. So they have spent months to rebuild the application. So after that, there are two things which we can get. That is, after they revamp it, they up the conversion rate and also the page views by plus 25%, and infrastructure required minus 50, and availability now they have 99.94% from 99.71. So this is a real example. That is the first point. The second point is, as a company, can we do like that? Can we spend months to rebuild or redesign a site? Or if customer complains about the performance and after we, there are a lot of users, can we do that as a company? So we need to think about that. Finally, so business success is about technology, performance, plus happy customers. So you can see a bunch of happy customers. Okay, thank you, everyone. So if you have any questions, please email me, and you can buzz me as well. So thank you for listening.